Assalamu alaikum. This slide is in continuation to the last slide. Hypothesis testing 1 is before this one, and this is hypothesis testing 2. That's why the slide numbers are in continuation from the last slide.
Slide number 13. Yates corrected chi-square, also known as continuity correction. Actually, let us see what it's defined as. If one or more of the expected frequencies is less than 5, then Yates correction formula, also known as continuity correction, is applied to make the test statistic more accurate. In calculating the chi-square, we have seen in the last exercise, for each observed frequency, we calculate expected frequency. And if any expected frequency is less than 5, then we are supposed to apply the Yates corrected formula. What is the difference between these two formulas? That is, if any of the expected frequency is less than 5. If one or more than 1 is less than 5, then you have to apply the Yates corrected formula. Okay. The chi-square formula is observed minus expected square over expected value, and we solve one problem here. If you found any expected frequency less than 5, 1 or more, then the Yates corrected formula is we further subtract from the numerator 0.5. From the absolute value of the numerator, we subtract 0.5 and then we square it. That is, it will result in reducing the numerator, and therefore the Yates corrected value will be smaller than the value obtained from the actual formula. It is always less than the chi-squared statistic. Okay, we will take an example, show that one. Now, for a 2 by 2 table, that is, if you have two categories for both the variables, then it is advisable to use the Yates corrected formula always. That is, if you are given a 2 by 2 table, then you are going to use the Yates corrected formula. And if it is a table bigger than this one, 3 by 2, 4 by 4, like this, so in that, if any expected frequency is less than 5, then you are going to use the Yates corrected formula. Formulas are given to you in the examination. Chi-square formula and chi-square corrected will also be given to you. Slide number 14. One exercise has been taken here in which the Yates corrected formula shall be applied. You are given a table, smoking and disease. This is the given to you, this table, and here your hypothesis as usual H0 will be no association. Disease and smoking are not associated, and alternate they are associated. Okay. Now you want to check whether the Yates corrected formula will be applied or will not be applied. So you get if you are able to you get the minimum expected frequency. If that is less than 5, then you will apply the Yates corrected formula. Okay, for minimum expected frequency, select the minimum row total and minimum column total and obtain the corresponding expected frequency. So minimum row total is 20, minimum column total is 20, grand total is 100, and therefore your expected frequency for this will be equal to 4, which is less than 5. That means the Yates corrected formula is to be applied, and Yates corrected formula is difference between the two frequencies, their positive value, subtract 0.5, take the square, and then divide by the grand total. So here, as we did in the last exercise, the table shows, the first column shows the observed frequencies for all the for all the observed frequencies are given in column 1. You need to calculate expected frequencies as you did in the last example. For each observed, row total into column total divided by grand total, and you will calculate only 3 remaining you can get by subtraction. Now from the difference of these two, further subtract. For the first one the difference is 5. Subtract 0.5 from them, so it will be 4.5. Similarly for the second one, again 5, it will remain 4.5. For the third, the difference is 2. 2 minus 0.5 means 1.5. So you get this difference as shown here, and square it, divide by the corresponding expected frequency, and you will get for each one like this, and this is the test statistic value 4.95313. Here the test statistic is this one. Just now we calculated using the Yates corrected formula, and degree of freedom is equal to 2 rows means 2 minus 1 into 3 minus 1, that is 2. DF is 2, and critical value table will give you P more than 0.05. We will again see this in the table, and because P is more than 0.05, you will accept the null hypothesis, that is smoking and disease are not associated. Okay, this is how we can use the Yates corrected formula. In the next slide we will see how we got P more than 0.05.
Slide number 15. You are familiar with this table. This is the critical values for chi-square test. The p-values are shown in second row, and these values are the standard test statistic values, and the degree of freedom column is the first column here, and p equal to 0.05, this is the main column which will decide whether you are going to accept the hypothesis or reject the hypothesis. If your calculated test statistic is to the left of this value, then you will accept S naught, and if your value is to the right of this value, you will reject S naught. In the last example, the test statistic was calculated as 4.953 and degrees of freedom as 2. If degrees of freedom is 2, means you will be looking in the row which is corresponding to 2DF. Now here first you will compare your test statistic with the p equal to 0.05, which is 5.99. Now your value 4.953 is less than this one, and therefore you will accept the hypothesis, that is your p is more than 0.05. P is more than 0.05, and you will accept the hypothesis. One thing I think I forgot to explain there. When you are rejecting the hypothesis, then you are supposed to mention the percentages to describe the type of association. But when you are accepting the hypothesis, that means there is no association, then no need of mentioning the percentages. Okay. Slide number 16. An example is given here, and some information is given in the example. Using this information, first you have to create the table, and then you have to calculate the chi-square value, test statistic, and the rest is as you did before, that after calculating test statistic and knowing the DF, you will be using the critical value for standard chi-square values table, and then you will get the p-value, and if p-value is
less than equal to 0.05, then you will reject S naught. And when you reject S naught, then you need to mention the percentages to describe the type of association. Okay. Steps will remain same as we have discussed before. Whenever you are testing a hypothesis, first we have to write the null hypothesis, then alternate hypothesis, then the formula which you are going to use to calculate the test statistic. Here we have only discussed the chi-square test so far, and then the calculated value will be compared with the table value, and from the table you will get the p-value, and p-value will decide whether you are going to accept the hypothesis or you are going to reject the hypothesis. These are the steps in all the statistical test significances. You have to use this procedure. Now let us come to this example. Your study is to find the association between BMI and cholesterol. 300 adult persons were chosen randomly from a population. Their BMI and cholesterol were recorded. Among the 300 persons, 80 were found obese and cholesterol of 90 persons was found to be high. Among those who had high cholesterol, 35 were the obese persons. You are given that cholesterol is to be taken as independent variable. Okay. We prefer to take independent in the column because that helps us to make a comparison with the percentages easily. We have discussed this in the frequency table, in the cross tabulation. The question here is, can you say that BMI and cholesterol are associated? For the answer of this question, you will calculate the chi-square value and you will compare that at p equal to 0.05. And if your calculated value is more than that value, critical value of the table, then you will reject S naught, that is yes. We can say that BMI and cholesterol are associated. Second part is if yes, give the level of confidence and describe the type of association. We have seen that first we get the p-value from the table, then from the p-value we calculate the level of confidence by the formula 1 minus p into 100, and that has been asked here. Okay, let us start it. First we will write the null hypothesis, that is BMI and cholesterol are not associated. Alternate, they are associated. Now you have to prepare your table. From the given information, you are given the total 300 individuals were included in the study, that is total is given 300. Okay. Next you are given that 80 were found obese. Obese means BMI more than equal to 28, that is 80 are obese. And 90 were found to be with high cholesterol level. High cholesterol level is 90 here. Okay. Further given is that among those who had high cholesterol, 35 were obese. Among these 90, obese are 35 here. Now you can complete it because totals are given to you. You can complete 300 minus 80 will give you 220, 300 minus 90 will give you 210, and using this 35 you can get other three cell values, 90 minus 35 and then 80 minus 35 you will get 45, and then 210 minus 45 you will get. So you have completed the table. Now what formula you are going to use here? Chi-square. Remember when we were discussing the Yates correction formula, Yates correction formula is used when any expected frequency is less than 5. Also, Yates corrected formula should be used when your table is a 2 by 2 table. It is a 2 by 2 table. Both the variable have two categories. It's a 2 by 2 table. That means you are going to use the Yates corrected formula here. And the Yates corrected formula is given like this. I am not calculating this, we have been explained. Just make a table on some paper with you and write the observed frequencies, calculate the expected frequencies, and then take the difference, further subtract 0.5 from the difference as explained for Yates corrected procedure, square it, divide by corresponding expected frequency. You can see the last slide and you will get the chi-square value. The test statistic you will get 8.949. I want you to verify this one. And what is the degree of freedom here? Degree of freedom will be 2 minus 1 into 2 minus, that is, it is equal to 1. When you will be using the table for getting the p-value, the for test statistic 8.949 and df is 1, you will get p less than 0.01. If p is less than 0.01 means you are going to reject the hypothesis, that is, there is association between BMI and cholesterol. The question is about also the level of confidence. The confidence level you will get by the formula 1 minus p into 100, and it is more than 99%. Now, to describe the result, percentage of obese among high cholesterol, you will get the percentage 35 out of 95. It will be equals to 38.9, and of among normal cholesterol it will be 28.4. That is, it's showing that the prevalence of obesity is lesser among the normal cholesterol individuals. That means high cholesterol increases the chances of the obesity among the persons, and this you can say with more than 99.0% confidence. Slide number 17. There is a similar problem which was discussed in the last slide. It's a 2 by 2 table, and here it is to see the association between physical exercise and diabetes. You will be following the similar steps. That is, first you will write the null hypothesis, physical exercise and diabetes are not associated. Alternate, they are associated. And because it is a 2 by 2 table, you will be using the corrected chi-square formula, Yates corrected formula. And you will complete the table as you did in the last example. The information which is given to you, you will put in the cells the uh, respective values, and you will get the complete table. Once you have the table, you can calculate the chi-square value using the Yates correction, and you will see that you will get the calculated test statistic as 13.120. DF is equal to 1. It is a 2 by 2 table, and you will be using the uh, critical value table to get the p-value. The p-value is given here. I want you to get yourself, and the background, the color has been changed of the text. You can check yourself what is this value, and then you can verify your result. Also, the level of confidence. Once you have the p, you can get the level of confidence. Also, the percentages, you will find that among non-exercisers 40% and among exercisers 15%. That is, it shows that the exercise is effective in controlling the diabetes, because among exercisers only 15% are diabetic, and among non-exercisers more diabetic, 40% diabetic. So it is exactly same as the last slide. You can solve it and you can check the result from the given results. Slide number 18. Z test for proportion. Please recall when we were discussing the normal distribution. After the normal distribution, we explained the standard normal distribution. And it was also explained to you that whenever Z is mentioned anywhere in statistics, it means it is the standard normal variable. Standard normal variable means this variable follows normal distribution with mean equal to 0 and variance equal to 1. Variance means SD1. So we are going to discuss this test. This test is used to compare two different populations with respect to the prevalence of a certain attribute. When we are having two groups and we want to compare the prevalence of certain characteristic, say diabetes, hypertension, increased triglyceride, or any other thing, we are using this test, Z test. We can also use this test for association. We use the chi-square test for finding the association between two categorized variables. This can also be used for association, but it is restricted only on a 2 by 2 table. If you have 3 categories or 4 categories, then this test cannot be used. And if it is a 2 by 2 type table and you are looking for the association, then this test is preferred to chi-square test when prevalence is very, very small. If you are having a sample size, suppose 200, 300, and you are getting only 3 or 4 disease persons or a small number, maybe 10 or 11 like that. So in that case, this is preferred to chi-square. We prefer to use the Z test for proportion instead of the chi-square. So now we are going to discuss the Z test for proportion. Slide number 19. Z test for proportion. The formula for this test. We have seen that we discussed in the last slide that this is used to compare two samples to different populations when we want to know we want to compare the proportion or the prevalence of certain disease or certain characteristic. If both the samples are 30 or above, then the formula for that test is given as P1 minus P2 over P into Q or 1 over N1 plus 1 over N2. Remember, that is a standard normal variate. And you must be remembering that for Z variable, 95% value is 1.96. And Z value at 99% is 2.58. You have to keep this in your mind or memorize these two values. 99% value of Z at 99% level of confidence and at 95% level of confidence. Now here Z is standard normal. We have already explained that one. N1 and N2 are the sizes of the sample of the two groups, and P1 and P2 be the proportion of the certain attribute in the two groups. I will take an example which will make the things more clear. And P is the combined proportion of the combined group, and Q is 1 minus P. That is, if you have P1, P2, PQ, N1, N2, you can calculate the value of Z. And if the value of Z, we take its absolute value when we compare with the table value, its standard normal table is given in a different way. So you need to memorize the 95% and 99% values. If your calculated value of Z, positive value of Z, is more than 1.96, then you will reject the hypothesis at 95%. And if it is less than 1.96, you will accept the hypothesis. If it is more than 2.58, means you will reject the hypothesis with higher level of confidence, that is 99%. Okay, I will take an example, then it will be more clear to you. Slide number 20. One example has been taken here, and it will make the things very, very clear for Z test for proportion. The exercise is to compare the prevalence of diabetes among males and females. 80 males and 100 females were randomly selected from the population. 8 males and 15 females were found to be diabetic. Use proportion test to test the significance of difference between two proportions. Okay, you are given the information, and you want to test the hypothesis for test comparing the proportions of the males and female proportion of diabetic in the population. As usual, the steps are there. That first step would be writing the null hypothesis, always of no difference or no association, means prevalence of diabetes is same among males and females. There is no difference. P1 equal to P2. And alternate, not same. P1 is not equal to P2. The formula for that, the formulas are given to you. The formula is this. This will be given to you. Now, if you know N1, N2, P1, P2, PQ, then you can get the value of that. N1 is the size of the first sample, which is equal to given to you 80. N2 is the size of the second sample. It is for the females, it is given to you as 100. P1. P1 means proportion of diabetic in among males, that is first sample. The proportion you will get number of diabetic persons upon the sample size. You are given that the number of diabetic among males was 8 and total males were 80, and therefore P1 equal to 8 over 80 means 0.1. Similarly, P2 will be the proportion of diabetic among females. 15 were found to be diabetic and the sample size was 100. It will be 15 upon 100, that is 0.15. You got N1, N2 given to you, P1, P2, you obtain from the given information. P is the proportion in the combined, that is combined males and females. The sample size will be 180 and number of diabetic will be 8 plus 15 means 23. So your P will be equal to 8 plus 15 over the sum of the two sample size, 0.128, and Q will be equal to 1 minus P, that is 0.827. Just substitute these values in the formula. We always take Z as positive, that's why in the numerator it has been taken the absolute value of 0.1 minus 0.15, your value equal to 0.998. You will compare this value at P equal to 0.05. P equal to 0.05 means 95% confidence, and for 95% confidence the Z value you know is 1.96. That is, you will compare this value with the 1.96, and because this value is less than 1.96, you will accept the hypothesis. Your test statistic is 0.998 and your critical value is 1.96. So your test statistic is less than critical value, hence you will accept the hypothesis. That is, the prevalence of diabetes is same among males and females. When the prevalence is same, no need to mention the percentages or the proportion. If this would have been significantly different, means P would have been less than 0.05, then you would have mentioned the sample proportions. That is because among females the proportion is high than males, means the prevalence of diabetes is more among males and females, and also in that case we mention the level of confidence also. Whatever be level of confidence, 1 minus P into 100. So when we reject the hypothesis, then we mention the sample information just to describe the result in detail. Okay. Slide number 21. When we started explaining the hypothesis testing procedure, we also discussed, it's very important, we also discussed the types of errors in hypothesis testing. Sometimes we reject the hypothesis when it is true, and sometimes we accept the hypothesis when it is false. So errors are termed as type 1 error and type 2 error. You should know which is the type 1 error, which is the type 2 error. Also, you were explained that whenever we write the statement or when we refer the result, we always mention H naught. Either we are accepting H naught or we rejecting H naught. Now the question is, in hypothesis testing procedure, the two types of possible errors are type 1 error and type 2 error. You are supposed to know which error is known as type 1 and which error is known as type 2. Type 2 error is defined as rejecting H naught when H naught is true, accepting H naught when HA is false. We are going 4 options. Let us see one by one. Rejecting H naught when H naught is true. This is some error. Now you have to decide, is it type 1 error or type 2 error. Second is accepting H naught when HA is false. If HA is false means H naught is true because the two are complementary to each other. So this B is not an error. B is a correct statement. It is correct decision. C, rejecting H naught when H naught is true. When H naught is true means HA is false. It is also a correct statement. It's not an error. And the fourth is accepting H naught when HA is true. Means you are accepting H naught when HA is true. That is, HA is true, but you are accepting H naught. So the first and last are the false statements, errors. It's not a statement false, they are the errors. Now, which is type 2 error? Type 1 error is rejecting H naught when H naught is true. And type 2 error here is accepting H naught when HA is true. This is the type 2 error. The second question, type 1 error is defined. I hope you should do it to your own. What is type 1 error? Type 1 error is rejecting H naught when H naught is true. See which statement is that? Rejecting H naught when H naught is true. The second one is given there. So this is, to be prepared for such type of questions. Most of the questions will be based on the concept. Okay, some more questions. Slide number 22. It's a very good question. It was part of the examination, I think, last year or before last year. To test the significance of association between characteristic and disease, you want to apply chi-square test on the following tables. You are given two tables. The column variable has 3 categories. The row variable has 2 categories. Okay. Yates corrected formula should be applied on. You are given table A and table B. Yates correction formula, you know that if the table is 2 by 2, then we apply Yates corrected formula. If the table is larger than this 2 by 2, that is 3 by 2, 2 by 4, 3 by 4, like that, then if any expected frequency is less than 5, then we apply the Yates corrected formula. Now here you have, the question is whether Yates formula will be applied only on A or B or on both or none of them. So for that you need to see the minimum expected frequency in both the tables. The table A, find out the minimum expected frequency. The formula for expected frequency is row total multiplied by column total divided by grand total. So the minimum will be the one which is having the minimum row total and minimum column total. So the minimum expected frequency for table A, the minimum row total is 30. There are only two rows, 70 and 30, it is 30. And the minimum column total is 25. And you get the corresponding expected frequency. 30 into 25 over 100 means 7.5. Means it is more than 5 or more, and therefore on this table Yates corrected formula is not required. See in the second table for table B, minimum row total is again 30 here, minimum column total is 15, and the minimum expected frequency will be equal to 4.5, which is less than 5. That is, on this table you need to apply the Yates formula. Which option is correct? Option number 2 is correct. It was explained to you when we use the Yates formula, and that may be asked, was asked in like this. Slide number 23. This question MCQ is actually based on the use of the critical value table. That is how to get the p-value when test statistic and degrees of freedom are given to you. And the question is, chi-square test was applied to test the significance of association between characteristic and disease, and test statistic was calculated as 14.224. Test statistic is given to you. Now, in the second paragraph, select the most appropriate option from the following for the p-value. It is given that both characteristic and disease had 3 categories each. That is 3 rows and 3 columns. So this information will give you the degrees of freedom. Number of rows minus 1 into number of columns minus 1, that is degrees of freedom equal to 4. So now you had test its statistic 4.224 and the degrees of freedom 4. You know how to get the p-value for the given test statistic and DF. I am only mentioning the values here. Table will be given to you here for the 4 DF. For the when DF is 4, and if you see the table, the 4 DF table is here. DF is 4 and the values are given here. First row gives the p-values, and your test statistic is 14.224. 14.224 lies here. That is, p-value lies between 0.01 and 0.001, and therefore the most appropriate option is p less than 0.01. Okay, all the best. Good luck. Slide number 24. I thought that only 23 slides are there. Now I found there is one more slide, and it is also having 2 MCQs. Okay, let us see this one. Z-test for proportion was applied to compare prevalence of increased triglyceride among males and females of a population. Okay, 20 males and 30 females were randomly selected from the population, and combined prevalence, combined means the both male and female, 50%, was found as 30%. That is 30% of the total sample were found as having high increased triglyceride. If 10 females were found with increased triglyceride, then number of males with increased triglyceride is. Okay. It's very simple question, simple mathematics. Either 4 or 5 or 6 or more than 6. You are given 30% are having increased triglyceride, 30% of 50. 30% of 50. The prevalence is equal to, it is 50, the overall prevalence is equal to 30%, and how many will be the having the increased triglyceride, because the question is about the numbers. So 30% of 50 will be equal to 15. That is, total 15 persons in the combined sample are having increased triglyceride. Females are 10, and therefore how many males left? 5. So your answer is this. Simple question. I think there is one more question. Z-test for proportion was applied to test the hypothesis P1 equal to P2 versus P1 not equal to P2. Okay. If test statistic was calculated as 1.952, then select appropriate option for p-value from the following. P is more than 0.05, P is less than 0.05, less than 0.01, less than 0.001. You remember at 95% the value of Z is equal to 1.96, and your value is, this, remember these two, and your value is 1.952. This is even less than 1.96. And if it is less than 1.96, then you are going to accept H naught. That is, you are accepting H naught means P is more than 0.05. Okay, good luck. Now this chapter is finished.